Okay, this is lesson 2.1 independent practice, and this is page 35. And this is going to be the second part of this, or this is the second video from page 35. We're going to do the word problems at the bottom of the page, 19 through 22. And I'm going to get out a little whiteboard here and show you how I would solve these. Okay, question 19 reads, Carlos is arranging books on shelves. He has 24 novels and 16 autobiographies. Each shelf will have the same number of novels and autobiographies. If Carlos must place all of the books on shelves, what are the possible numbers of shelves Carlos will use? I want to draw your attention that this is a pluralized answer and that it doesn't ask for the greatest number of shelves he can use. This is not a greatest common factor question. This is a common factor question. So we got to use our context clues to answer that. So number 19, we're looking for the factors of 24 and 16. So I'm just going to list all the factors. Factors of 24 include 1 and 2, 3, and 4. Those are all the smaller factors of 24, and then I'm going to find the partners. It's going to be 4 times 6, it's going to be 3 times 8, it's going to be 2 times 12, and it's going to be 1 times 24. So to make sure that we got them all, we can just use a rainbow method, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So that seems about right. The factors of 16 include 1, 2, 4, and then it's going to be 4 times 4, so that kind of gets its own partner. It's going to be 2 times 8, and it's going to be 1 times 16. So I'm going to use an upside down rainbow method, and then 4 is times itself. So now what I need to do here is go through and find the common factors. 1 is a factor of both 24 and 16, 2 is, 4 is, and 8 is. So while that's a little bit messy, I have answered the question. So what I'm going to do here is make a little bit of space on my line. And my answers include 1, 2, 4, or 8. And then I have to answer the question. It says, what are the possible numbers of shelves? So it's 1, 2, 4, or 8 shelves. That is the answer. Okay, let's move on to number 20. So I'll rearrange my board here so I have plenty of room here. And number 20 reads, the middle school band has 56 members. The high school band has 96 members. The bands are going to march one after the other in a parade. The director wants to arrange the bands into the same number of columns. What is the greatest number of columns in which the two bands can be arranged if each column has the same number of marchers? There's a follow-up question, how many band members will be in each column? So let's go reread this and decide what kind of problem it is. What is the greatest number of columns in which the two bands can be arranged? That word greatest means this is a greatest common factor question. So I'm going to go ahead and identify the greatest common factor of 56, which is the middle school band, and 96, which is the high school band. And this probably doesn't require, but it sure would be helpful to have a multiplication chart. And what you do is you scan your multiplication chart for 56 and 96. And when you find 56 and 96 in either the same row or the same column, you then go find that factor. That's one way to do it. You could also list the factors of 56, which include 1 and 2 and 4 and 7. And it's going to be 7 times 8, and that's important to know. That'll be important later. And how many times does 4 go into 56? That's 14. And 2 goes into 56 28 times. And 1 goes into 56 times. So I'm going to use my rainbow method, make sure I get them all. 4 times 14, 2 times 28, and 1 times 56. So now the factors of 96, it gets a little bit harder here. It's going to be 1 times, I'm going to do this kind of in this way. It's going to be 1 times 96. It's going to be 2 times, remember that rule, even numbers, the last factor is itself. And the second to last factor is exactly half. Half of 96 is 48. And 3 actually is a factor of 96. It's not super important to realize that because 3 is not a factor of 56, but still important to figure out how many times 3 goes into 96. 3 goes into 96 32 times. 4 is a factor of 96. 4 goes into 96 24 times. 5 is not. 6 is. 6 is a factor of 96. 6 goes into 96 16 times. 8 is a factor of 96, and that's important. 8 goes in 96 12 times. Now, if you had a multiplication chart, you could check these. It's going to be 8 times 12, 6 times 16, 4 times 24, 3 times 32, 1 times 48, and 1, I think I said it's 2 times 48, and it's 1 times 96. Now, this is a greatest common factor question, so what I need to do is go carefully find the greatest common factor. 1 is in both lists, as is 2, 4, 8. And if you look carefully, you won't find another number. So what does that mean about this answer? First of all, it means that the greatest common factor is 8. So let's go reread both questions. It says, what is the greatest number of columns in which the two bands can be arranged? So the answer is 8 columns. The greatest common factor is 8, so the answer is 8 columns. Now the second question is just a little bit tricky. The second question says, how many band members will be in each column? So I'm going to tell you how I can understand this. I'm going to change color here and draw your attention to what I did earlier in my rainbow method. This right here means something. It's important to know what that means. That means 8 columns of 7 members. So if you had 56 band members, they do, by the way, you could take those 56 kids and divide them into 8 columns, and in each column would be 7 members, 7 kids. That's important to know. And then we already decided that 8 is the number of columns, so I'm going to go find my 8 here and check out this partnership. It's going to be 8 times 12. Well, there's more kids in the high school band, so that's not going to mean the same thing. It's going to mean what 8 times 12 means is 8 columns, just like we had before, but it's not going to be of 7 members, it's going to be of 12 members. Now, if you're wondering why I'm pointing all this out to you, we've got to go reread that question one more time. It says, how many band members will be in each column? Well, we just decided that it's going to be 7 middle schoolers, but it's also going to be 12 high schoolers. Well, how many kids is that? We have to add those. And so this second part of our answer is, and I need to erase to make a little bit of space here to write my answer. The second part of our answer is 8 columns with 19 members in each column. That is definitely probably the hardest problem on this page. So if you followed along, good job. It's a little bit tricky. If you got it wrong, please fix it. I think some kids might have said, and it's not a terrible answer, they might have said 8 columns with 7 middle school kids and 12 high school kids. And that's a good answer. I just combined them to make 7 plus 12 is 19. All right, let's go ahead and move on. Number 21. This is going to be one of the easier ones, which is kind of cool. Let's check this out. 21 reads, for football tryouts at a local school, 12 coaches and 42 players will split into groups. Each group will have the same number of coaches and players. What is the greatest number of groups that can be formed? Again, when you see this word here, it indicates to you that it's a GCF problem. So that means that for 21, we need to find the GCF of 12 and 42. And my favorite way to do this is just to list the factors. Factors of 12 include 1 and 2 and 3 and 4 and 6 and 12. The factors of 42 include 1 and 2 and 3 and 4. 4 does not, I changed my mind on that one. It's going to be 6 and 7. And 3 goes into 42 14 times. And 2 goes into 42 21 times, and 42. So now what we need to do is make sense of, our answer and how we can, there's 2 questions here, so I want to show you how you can use the rainbow method to get your second answer. So let's just do the rainbow method. That kind of checks that we got them all. So the factors of 12 include 1 times 12 and 2 times 6 and 3 times 4. And the factors of 42 include 1 times 42 and 2 times 21, 3 times 14, and 6 times 7. And check this out here. I'm going to show you how the rainbow method gives you both answers, okay? So what's our greatest common factor? Well, the factors in both lists include 1 and 2 and 3, not 4, but 6. And that's the greatest factor of both is 6. So right off the bat, we could come over here and write 6 groups. Because the first question, what is the greatest number of groups that can be formed? 6 groups. Now let me show you how you can use the rainbow method to answer the second question. The second question asks how many coaches and players will be in each group. So check out how we identified that the answer is 6. Well, check out 6's partner. I'm going to draw an arrow from 6 to its partner. It's going to be 6 times 2. So if you think about it, how many coaches, this is the coaches, I'll put a C for coaches, and this is the players. If you think about it, if you had 12 coaches and you made 6 groups, it would be 2 coaches in each group. So the partner of the greatest common factor is the second answer. 6 groups with 2 coaches, and I'm going to do the same thing with the players, but we had a total of 42 players, so we got to go to 6 and look at its partner, and it's going to be 7, 6 times 7. So that means that it's going to be 7 players in each group. I don't really have enough room to finish my sentence, but if I wanted to write a sentence, I would write, you could make 6 groups with 2 coaches and 7 players in each group. Now I realize it's different. Number 20, I combined 9 and 12. I think it was 7 and 12. I combined them to get 19. So my answer for 20 looked a little different than 21. But it's because in number 21, I feel like they're asking me to list the players and the coaches separately. You wouldn't combine them. If for some reason 21 said how many people would be in each group, then we would add 2 plus 7, and our answer would be 6 groups with 9 people. But it doesn't ask that, so let's go ahead and move on to number 22. And this one is a little easier than it looks. Some kids get this one wrong because they don't get all the factors here. It says Lola is placing appetizers on plates. She has 63 spring rolls and 84 cheese cubes. She wants to include both appetizers on each plate. Each plate must have the same number of spring rolls and cheese cubes. What is the greatest number of plates she can make using all of the appetizers? So that right there indicates it's the greatest common factor problem. And then just like the last problem, how many of each appetizer will be on each plate? So we need to find the greatest common factor of 63 and 84. And this is one where if you use a multiplication chart, you'll be a little bit better off. In fact, I might try this real quick. I might pull up a multiplication chart and show you what I would do. So I'm just Google searching an image here, and I think this will work. So I wonder if, there we go, that's going to work, I think. So hopefully that's showing up pretty good on your screen. So what I'm looking for here, if I went back to my problem is I'm looking for the greatest common factor of 63 and 84. So if I go to a multiplication chart, what I'm looking for is I'm looking for 63 and 84 in the same row. So if I'm looking at rows here, I wonder if I have a mouse on here. Do you see the hand? So I'm going to go down here and I say, oh, look, there's 63. And right next to it is 64. So what does that mean? It means that 21 goes into 63. And it means that 21 goes into 84. And this, when I look up, it means 3 times, and it means 4 times. So what did I just tell you? Here's what I just told you. And if you didn't know this method for using this multiplication chart before, you're going to learn it now. So what I just learned is that some of the factors of 63 include, and I know 1 and I know 3 because I just saw that it's 3 times 21. So that means that 21 is a factor of 63. And in 84, I know 1's a factor of it, and 2. But those are not going to be the answer. It's not going to be 1. I know it's a common factor, but it's not going to be the answer. It's not going to be 2. It's going to be 4 times 21. So 21's in both lists. What does that mean? Well, it means that the greatest common factor of 63 and 84 is 21. So that means she can make 23 plates. The first question was how many plates she can make. And then put the word with here because the second question asks what goes on those plates. Well, here's what goes on those plates. 3, and I think the first number was spring rolls. 3 spring rolls and, check this out, 4 cheese cubes. That's the answer. That's how you can use a multiplication chart to get your answer super quickly. 3 plates with 3 spring rolls and 4 cheese cubes. Now, I know these can be a little bit complicated, but I'm sure you're noticing that with practice it just gets a little easier.